My name is Joseph McIntyre. I'm a research agricultural engineer at the USDA ARS National Peanut Research Laboratory. And here we study peanuts from field to, as my friend Chris Butt says, the peanut butter sandwich. My current research is into early detection of fires in peanut warehouses. These fires can be rather devastating as they involve several thousand tons of peanuts or cottonseed, and they can become catastrophic as they begin buried and smoldering in the pile, and they don't become evident until they can be very large. The way we're approaching the problem is investigating what emissions peanuts and cottonseed produce when they get hot. We've gone to the Missoula Fire Research Laboratory to have them collect the smoke from heated peanuts. And as you can see, it gets rather spectacular at the end. We go from little wisps of smoke to a bonfire in about 20 minutes. Here at the National Peanut Research Laboratory, we've reproduced the experiment and invited the Aerodyne company's mobile atmospheric lab, testing lab, here to investigate both peanut emissions, and we've added cottonseed. And you can see it doesn't look like it's done much, but you can get rather cooked and smoky on the inside without it revealing that you've started a fire. Beyond the fire research, we have other projects about investigating peanuts and improving processing here for peanuts at the lab. We have an ongoing project to reduce the noise produced by peanut dryers. And it's interesting, a peanut dryer and a jet engine are essentially the same device. They both heat and blow air, and they make quite a bit of noise. We're looking into ways to adapt mufflers to go onto the peanut dryers and use jet engine silencing technology in a partnership or research project with the NASA Aeroacoustics Laboratory at Langley, Virginia. Beyond fire and noise, we get into actually how strong peanuts are, which is applied to shelling and processing. We compress and test peanuts using a universal testing machine that's typically used to test bolts and other engineering materials. And here I have the fanciest nutcracker around. We squeeze the peanuts and find out how much force and essentially compression they take before they crack. We've noticed from research that they can vary quite a bit, and this shows up in shelling and processing, because fragile peanuts tend to break in the field while you're harvesting them. Then we're looking into using imaging to advance the study of peanuts for the other researchers here at the lab. We can use thermal imaging to see how peanuts respond to drought conditions, whether they heat up or cool down depending on how much water is available. And using time-lapse photography, we can watch the peanut leaves open and close and change their position throughout the day based on how much sunlight they're getting. Turns out they dance around quite a bit for a plant. We've applied this to an experiment to see if this folding and unfolding was affected by herbicides as a method of trying to control water usage in the peanuts. And then we can do measurements using photography that lets us analyze the image and give us precise measurements on how big things are, how many nodules are on the roots, just from taking a picture instead of going by hand using a ruler. Thank you for coming.